Okay, so now we are solving matrix equations. So again, just adding tools to your toolbox. So when we're solving matrix equations, right, if I have, let's say, cx plus a equals b, well, then it's pretty much exactly what you would think. If I'm going to subtract over the a, subtract the a, come over here. Then I have cx equals b minus a. And then, well, actually, instead of saying divide by C, because fun fact, we learn more about this later on, but division doesn't actually exist for matrix equations. Okay, for matrices, division, not a thing. I know, who would have thought? So technically what we do is we multiply each side by C's inverse. So we get into more detail about that in 6.4 when we talk about inverses, but here's just a little nugget of info. But again, or not again, for the first time, pardon me, that is how we can solve matrix equations. So just adding tools to your toolbox and how to solve these systems using matrices. So if I want to solve for the x, so the capital X is the variable matrix. In this case, it would be a 2 by 1, so just x comma y. But again, we talked more about that in 6.4. So if I'm just solving for x in general, what we would want to do is first subtract over a, subtract a, so 2 times the variable matrix x equals b minus a. So if I'm just going to actually do that here. So that 2 times matrix x equals, okay, so bear with me. So that's -6 minus 1 is -7. And then that's 5 minus -5. So 5 plus 5 is 10. 9 minus 0, right? Because it's b minus a is 9. And then 1 minus 2 is -1. Perfect. And now what's the opposite of, or what's the opposite of multiplying by 2? Now I know you want to say divide by 2, but remember division doesn't exist. So we don't say divide by 2, but we say multiply by 1/2. And whatever we do to one side, y'all know we have to do to the other side. So the variable matrix x is equal to -7/2, 5, 9/2, and then -1/2. There you go. Okay, so our variable matrix, so this is kind of, sorry, going back to this. I feel like I'm all over the place. I hope you're keeping up with my crazy brain right now. This is for 6.4, just giving you kind of a nugget, a breadcrumb of what's to come. But anywho, for our equation, we have the variable matrix x is equal to -7/2, 5, 9/2, and -1/2, because we just ran the scalar of 1/2 through. That's it. Okay, so now matrix multiplication. It's also row by column matrix multiplication, so also known as row by column multiplication, matrix multiplication. This one, I'm going to write it down. And at this point, you can just kind of like blindly follow along. I will explain as I go. Maybe my brain will wait and explain at the end, but it is very wordy, mathy, if you would, the definition. So just bear with me and then I'll clean it up. So here we go. The product of an m by n matrix A and an n by P matrix B is an m by P matrix AB, whose element, oops, sorry, I'm off the page, let me switch, whose elements are found as follows. Whose elements are found as follows. All right, here's where things get squirrely, so get ready. I'll even change colors for visual effects. The element in the ith row, so just some random row, the ith row, and jth column, so random j column, so they're overlap, of AB is found by multiplying each element in the ith row of A by the jth column of B. Okay, right? Clear as mud. So the product of an M by N matrix A and an N by P matrix B is an M by P matrix AB, whose elements are found as follows. Okay, so pause. Really, really important. We can only perform matrix multiplication some of the time. It's not automatically like an okay thing to do. It's not automatically approved. So when you're multiplying matrices, so here off to the side, let me scoot the page over, sorry. You have this M by N multiplied by an N by P. So whenever you're multiplying two matrices, the column on the left and the row on the right have to be the same number. They have to equal. The resulting size is the outside numbers. Okay, that's how you get the row and column size. So if these two numbers are not the same, then you cannot do the multiplication. Okay, so that's the setup. So left hand and right hand multiplication for matrices is a big deal on what's on the left, what's on the right, because you'll see in the next example that maybe AB can be done, but BA might not be able to be done, because remember, we need these two inner numbers to line up. Okay, and then here's where you pat your head and rub your stomach. So basically, you're multiplying each element of a row with the column. Okay, so row A and like column B, and you're taking the sum of the product. So you would multiply, and add those products together. Okay, so multiplying each element in the ith row of A and joining, and by the jth column of B, and then taking the sum of the product. Let me add that in there. And then take the sum of the products. Okay, I know, still not very crystal clear. Let's look at the example. So first, can the multiplication be done? This is a 2 by 2. This is a 2 by 2. So are these two numbers the same? Yeah, so we're good. So we know that their resulting product size matrix should be a 2 by 2. Okay, so here, AB, let me change colors. Matrix AB will give us AB 1, 1, right, row 1, column 1. AB 1, 2, that's row 1, column 2. AB 2, 1, so row 2, column 2, or column 1, pardon me, and then AB 2, 2, row 2, column 2. So to get each element of this, it is the sum product of row 1 with column 1, and then the sum product of row 1, column 2 of B. So AB1 is row 1 and column 1. So it is 2 times 0 plus 3 times 5. Then for AB12, that's still row 1, but now column 2. So it's 2 times 1 plus 3 times 6. So for element AB21, that's now row 2, column 1. So we now have 4 times 0 plus 7 times 5. 2, 2 is row 2, now column 2. That's 4 times 1 plus 7 times 6. So 2 times 0 is 0 plus 15, that's 15. And then you have, sorry, let me scooch, sorry about that. So here 4, 0, right? Row 2, column 1. And then row 2, column 2 for this one and this one respectively. Pardon my page. Okay, and then so for element 1, 2, it's 2 plus 18 to give 20. And then 0 plus 35 to get 35. And then 4 plus what? 42 to give, excuse me, why can't I think what 7 times 6 is right now? Anyways, 46. See, this is why I need y'all. I need you to tell me what math is. I missed you. Okay, so that is multiply matrices, right? Super, super easy, not confusing at all. I know. Okay, so just gonna continue on. So a few more by hand and then I'll show you the calculator. Okie dokie. So matrices A, B, and are defined as A. What size matrix is this? 1 by 3. And B, what size matrix is this? This is a 3 by 1. So first, if I want to know what is AB, well, I always double check. Can the matrix multiplication even be done? How we do that is because remember, those internal numbers have to be the same. Now recall the resulting size, in this case is going to be a 1 by 1, are the outside numbers. So this says you're just going to element by element move across and down at the same time. So this is 1 times 4 plus 2 times 5 plus 3 times 6, right? So across and down, respectively, element by element. That's why the numbers have to match up in order to perform, because I can't have a mismatch amount, right? I can't have more in this row than I do this column. All right, so now let's see if I can add 4 plus 10 plus 18 is 32. I'm not that fast. I looked at my cheat sheet page. Okay, now pause the video, think about B times A. Okay, hopefully you tried and you didn't just keep watching. Remember, B is that 3 by 1. A is that 1 by 3. So can the multiplication be done? Sure can. The resulting matrix is going to be a 3 by 3. Okay, so now my brain can't handle looking at these left and right. So I need 4, 5, 6 times 1, 2, 3. So in this case, remember it's across and down, across and down, across and down. So it's just, there's no summation, it's just the product. That's why you get the 3 by 3. So 4 times 1 is 4, and then 8, and then 12. So now it's 5 times 1 times 2 times 3. So 5, 10, 15. And then 6 times 1 times 2 times 3 respectively across, yeah? So 6, 12, 18. There you have it. Okay, so now let me grab my handy dandy calculator. First check, can the matrix multiplication even be done? So can a 2 by 2 be multiplied by a 2 by 1, 2, 3, 4? Yes, it can. For fun, what's the resulting size? A 2 by 4. Perfect. All right, so I got my handy dandy calculator here. So second x inverse for the matrix, edit, matrix A, 2 by 2, enter, and then 4, 2, 1, 3. 4, 2, 1, 3. All right. Second matrix, edit. Okay, this time I'll scroll to B. It is a 2 by 4. 1, 2, 3, 4, 0, 2, negative 1, 6. Okay, so 0, 1, 2, 2, 3, negative 1, 4, 6. Remember, always check what you pop in if you're using a calculator, because this is the last time you're going to see what you've used. All right, so second quit to get back to the home screen. Now you're going to go back into the matrix, grab A. You can do the multiplication button or not. It doesn't matter. Your calculator will read it. Then go back into the matrix, grab your B, and then enter. And there you have it. So it gives us the 4, 12, 10, 28, 1, 8, 0, 22. And yes, you can also do the addition, subtraction, scalar multiplication with your matrix as well, right? Just using these operation buttons. But remember, division does not exist. Division with matrices doesn't exist. Okay, so if you've noticed, this is now A times B. Let me move my calculator out of the way. As you know, this is a 2 by 4 times a 2 by 2. So can the multiplication be done? Nope. C and E. That's it. And we're done. You survived 6.3. Y'all have an awesome, awesome day. And I will see you later.